Hello friends, welcome to our short video series on quantum physics and the work of Dr. Amit Goswami PhD. To know more about him and his work, please visit www.amitgoswami.org. This series is meant for audiences who have no idea what quantum physics is. Hence, the first logical question would be, what is quantum physics? Well, if you don't know, don't feel bad, because many great scientists also did not understand quantum physics. Like Richard Feynman, one of the brightest physicists of the post-war era. He famously declared, "I can safely say that nobody understands quantum mechanics." Let's go back in time for a while. For centuries, scientists worked with classical mechanics that was quite useful to calculate and predict the movement of macro objects, right from what we use in everyday life to movements of stars and galaxies. After several modifications and additions by various famous scientists like Galileo, Newton, Leibniz, and many others, classical mechanics looked perfect. With the advancement of technology, by 1920s, scientists now had the means to study the atomic and subatomic world. The world inhabited by subatomic particles like electrons, protons, and neutrons. What they saw in that world blew them away. The classical mechanics that is so accurate in the macro world becomes completely useless while dealing with subatomic particles. In fact, if macro objects around us start behaving the way quantum objects do, we are bound to think that we are under a magic spell. You heard that right. Magic. If the visuals did not make sense now, don't worry, we'll come back to it. Now back to science. Time for some hard theories and equations. Now don't get put off by the mentioning of equations, I assure you, they are quite harmless. Going back to the question we started with. Quantum physics is the physics that explains how everything works at extremely tiny scales. We are talking about subatomic particles here. Since subatomic particles make up all the matter in the known universe, it is almost okay to say that quantum physics explains how the universe really is. In 1925, Heisenberg published the equation of quantum mechanics. This equation could calculate and predict the movement of quantum particles. In the following year, in 1926, Erwin Schrödinger independently published another equation for the subatomic particles. These two are the fundamental equations of quantum physics. And these are, mark my words, equations for waves. Wait a sec. We have been using the word particles all along, right? How can we calculate particle movements using wave equations? They are two completely different things. So are the subatomic particles not particles after all? But how can that be? Don't we remember our school science textbooks? The atomic structure was shown as similar to solar system with neutrons and protons in the center and the electrons going around them in fixed orbits. In school, we were never taught that subatomic particles can be waves. Well, who wants to show reality to school children? The reality is not what we see. Niels Bohr, one of the pioneers of the field, said, "Everything we call real is made up of things which cannot be called as real." To start exploring quantum physics, we must first get a couple of things clear in our minds. Let's talk about waves. Waves can be at many places at the same time. Their properties are very different than that of particles. A particle, while in motion, clearly defines a path and is at one place at a certain point in time. Now, here is the paradox. Schrödinger's mathematics say that subatomic particles are waves, but they are also most certainly particles. How can the same object be both waves and particles? And even if they were, how is it going to affect our understanding of reality? Stay with us. We are going to demonstrate a little magic in our next presentation. Don't forget to subscribe to our channel to become a part of this journey.